I'm going to do my best to make a quick video about how to use microcontrollers, which is that little blue thing that you can hook up to the computer. You get Claude Code or ChatGPT to write you some codes for Arduino, which is the program that you usually use for microcontrollers like Arduino. This one is a Elegoo Mega 2560, which has a whole bunch of inputs and outputs. This is the screen I'm using here. I'll let you see what I've got going on. It's going to make a whole lot of beeping. Obviously, this is your 8x8 4-section output. I can't remember what it's called, max something. These are your switches, your limit switches. So it just completes a circuit. All it is just a contact. You'll see a bunch of speakers. Obviously the big one there. This is a little SFM27. These are little bitty piezo speakers, which are real high pitched. The type of stuff that you're going to need, other than some helpful cats. Obviously this is your main thing here. If you don't really know what you're doing, you have to have a multimeter. It just reads power and reads different ways of measuring power, like capacitance and resistance and all that. Speaking of resistance, you have resistors, which are just your typical little line with a thing in the middle, a little either clay or metal film thing right in the middle that resists current, and it's just how you control electricity. It's a lot to explain right now, and a lot I really don't understand. I sound like an idiot trying to explain it. You'll get DuPont connectors, which will let you connect, male or female ends into a breadboard, which is the white things you see. They make small ones and big ones, and then on the breadboard, you got to know how to use it. There's the long sides with the long wire, and then the bunch of little wires. And all it is basically so you don't have to wire nut everything, but some places you do have to wire nut things. You can see these DuPont connectors are real stiff, but most wires you'll see like flimsy wires, and also in the middle of these DuPont wires is actually a bunch of stranded wires. And you cannot push stranded wires into a breadboard unless you solder coat it, which makes it kind of stiffer. And doing this stuff, you will eventually need to solder something. The smallest thing that I can solder is these little LED strips. And each one of those wires, it's really tedious. And at this point, it's kind of hard for me to mess that up because I know the trick. But they do make other connectors for those LED strips. Those particular LED strips are just 3-inch sections that I cut off of giant rolls. So these things in the middle here, these little inline black things, you'll see that they connect to my main 12-volt power. This is my 12-volt transformer, just your typical one. A lot of these microcontroller projects will use 12 volts because that's the typical voltage that drives speakers and motors and solenoids and all that. So you can expect to at least have one. And you'll see all those little gray tab looking things. Those gray tabs, those are transistors, and the reason they're big and gray back there is because it needs to dissipate heat. Those tabs are like aluminum, and a screw can go through it, and then they can install those to a heat sink, because with transistors, since their job in the circuit is to switch the current from a small trigger. It's kind of like the little guy says, all right, open her up, and then the bunch of stuff comes through. It's a kind of silly way to explain it. But this right here, you see it just made this go off because it's a motion sensor. It comes with a lot of these Arduino or microcontroller starter kits. And a lot of these components, you'll just supply them power. See how this has 3 wires, that green, yellow, and orange. That's going to be a power, a ground, and a signal cable. A lot of things that have signals will, like temperature controls and all that, you'll just power a module and then it will send back some kind of signal that your microcontroller will process. I'm trying to think of anything else. These little blue things are going to help you attach your stranded wire to your breadboard, so you're basically getting something to screw down into something you can push down. You'll see that I'll have tons of resistors, those things I showed you in the bag, the things that dissipate dissipate extra current as heat, and they restrict the amount of current or voltage or the amount of power that goes to something. I'm not good at explaining these things. But they go in the breadboard kind of loose sometimes, so you need to be careful. You can pinch them back around and basically make the wire a little thicker, so that way they fit into there a little better. But for things that are as sensitive as microcontroller programming, anything that has a stray radio signal is going to come up as a kind of stray signal. So, for example, I'd never finished tuning this motion sensor, but because it is really sensitive, either radio waves could make it go off, or just the fact that that signal wire might not be in that hole as good as it could be. Ideally, you would solder every connection you could possibly do, because the transfer of electrons has to be exact, for the most ideal situation. But for something like this, you can just basically touch two wires together and it'll work. But if you take it apart, you're making a big, you know, change in electrical current that will get detected. So obviously, long story short, just use the right connectors and you're going to get lazy. You're going to be pushing stranded wire into breadboard holes, hoping it works. But just make sure you know what to do when you're troubleshooting, because that's one of the top things that could be wrong. I meant to mention it earlier. So from this power, this 12 volt power right here, it just goes, you'll have these standard barrel type connectors for 12 volts. This is a female, obviously the male. And then right there, it splices into some wire nuts. The way you can probably see this, I've got 3 of these little black things there. Each one inside of there, there's a glass fuse each inside of each of those, and they're each rated for a different amount of breakage current. One of them is for the subwoofer, one of them is for the LEDs, another one is for the Elegoo, the brain, the CPU, the microprocessor. It's got many names. And that way, if anything takes too much current, if it breaks, basically, if it pulls too much current, then that little wire inside of each of these little glass fuses, I would take them apart and show you, but I don't need to. It'll break and it'll cut the current, which will protect your devices. So anytime something does not work, that's one thing that you got to check, obviously. Let's think. So let me just show you a few more little random things. So I was telling you about, you'll get some parts from these assortment kits. For example, here's another type of display. And then on the back, you'll see some signal pins. And it's kind of like what I was talking about, where ground and VCC, where ground is your ground wire, VCC is your voltage current, voltage constant current, which would be, in this case, your 5 volt or 12 volt. I'm pretty sure this would be 5 volt because it's a microcontroller part. One thing that's important to know is that there's 5 volts, and then there's also low voltage general purpose input output voltages, which are more like 3.3 volts. And I'm actually not sure if 5.5 volts is considered a GPIO voltage, but you just basically, when you have AI, you can ask it anything. And for the most part, if you ask it to confirm what it tells you right after you ask it, like right here, it'll tell me something. It'll tell me the behavior, apparently, but you can just say, "Are you sure?" And then, just as an example, let's see what it says. And this would probably take like 15 seconds for it to actually tell me, because I don't think it's really going to try that hard. And for context of "Are you sure?", it said, "No, I'm not sure. I missed something. Resetting blah 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 on every idle." See, it's actually telling me a bunch of bullcrap, because earlier the fix that it did give me before I made this video, it was a good fix. So you can see that the AI is conditioned to give you results as to, it's trying to make you happy, basically. So you can see that actually I could read it. Look, it said logic is right. It ran a test on the computer. Basically, yeah, okay, honest answer, yes, I'm reasonably sure. So you can see that it did try. And this is Claude code running through VS Code, which is the main coding program that everyone uses. You can see that's the icon for it. And Claude Code is kind of expensive to use the good one, but I've seen that ChatGPT is really bad about lying to you and sugarcoating everything so it makes you happy. You always have to try to ask it to not sugarcoat it, and you really got to talk to it like it's a lazy worker that just wants to get paid and go home, because it won't think all the way through, because it could either give you a quick response if it thinks that that's what you want, because for something like this, if it were to run through the whole code base or my whole computer and run through all these back tests over, are you sure? It's going to be loading, and I'm going to say I'm mad. And obviously, they're not going to want to release a product that does that. So that's why you really have to know what to ask, because that, as stupid as that was, you can see that it tried and it could have easily just lied. And I could have read just this and then turned off the computer and went and stomped off and said, I hate AI. So you have to know what you're doing, because otherwise this would have taken a lot longer and I would have burned up components in the process. And I've done stuff like this before, but this was extremely straightforward. I'm really happy about how this went, because it just, I'm about to finally shove all this crap in the thing that's taking a bunch of space in my workshop. So I'm really happy that this is, I can get it out of the way. Okay, I guess that's it. There's a lot more to look at and all that. I feel like I've already been talking for 12 minutes. And one day I do want to go around and show just a bunch of junk that you'll be seeing if you're wanting to do microcontroller programming or just circuitry in general. And a lot of this stuff I've never used. I just bought because I had money to buy it to make a kit one day. And I'm really glad I did, because in total, you can probably say that that's $20 of our microcontroller parts and like $5 worth of wire, but you have to buy like $20 at least to get them all that crap, because you can't just buy one wire at a time. All the other components, that thing was like $6. That LCD screen, each of those switches is like $1 hardly. So this stuff is extremely, extremely cheap. So this whole thing, this, not including the speaker because it's salvaged, everything on this table is probably like $30, $40 of parts. So I'm really glad that I didn't really have to go and look for every little part, because I actually had all these components, like the speakers and obviously the resistors. Right there you see a thing that looks like a resistor right in the middle, but it's actually a diode. So there's plenty of other things that I can still explain. I'm not the best at explaining how circuitry works. I think I'm just good at showing you what you can do when you don't try very hard and you just let the computer do all the thinking. And then all you really have to do is just have the drive to do it, you know? So that's it. I'm going to be making more videos and talking about things that I don't know about. Bye-bye.